Hello friends, this video on determinant part 24 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 23. Let's take some theorem. The theorem says if A be any given square matrix, please note if A is any square matrix of order n, then A into adjoint of A is nothing but adjoint of A into A. You do anyway multiplications all the same, and that is nothing but determinant of A into I, where I is nothing but identity matrix of order n. And this formula is used to write the A inverse formula. I can show you. So if this is my A matrix and the adjoint of A matrix is like this, A11, A12, A13, the transpose version with cofactors, then if you see A into adjoint of A is nothing but A into I, so that is this matrix, correct? A into adjoint of A is nothing but A into I, and this is, with this I get A inverse is nothing but 1 by A into adjoint of I, correct? So how you got this is, see if you see this, A into A inverse is nothing but I. So this guy you have got this. Now if you both side, if you divide by A mod, correct, and this into A inverse, A mod will cancel. A inverse is nothing but, if you see, this guy gets cancelled, adjoint of A by determinant of A, and that's how you got this formula. Correct? So using this theorem only, we got the formula that A inverse is nothing but 1 by mod A into adjoint of A. Let's verify that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I for this set. We'll verify this. So what we can do is, the first thing is we have to find adjoint of A. And also we have to find determinant of A. Let's find determinant of A. This is nothing but 2 into minus 6 minus 4 into, 3 into minus 4. So this guy is nothing but minus 12 plus 12, that is 0. So my determinant is 0. Now the second thing is I have to find adjoint of A. So to find adjoint of A, I have to find cofactor A11, A12, A21 and A22. So let's find cofactor A11, which is nothing but minus 1 to the power 1 plus 1, 2 into, if you take A11, you cancel this guy, you are left with minus 6 into minus 6, and that is nothing but minus 6. Similarly, A12 is nothing but minus 1 to the power 3 into, you take this guy, cancel row 1, column 1, you are left with minus 4. So minus 4 into minus 1, that is 4. Similarly, you take A21, so this becomes minus 1 to the power 2 plus 1, 3 into, take this guy, first column, first row ignore, into 3, that is minus 3. A22, you take this guy, ignore the last column, last row, you get 2 here. So minus 1 to the power 4 into 2, that is 2. So I have all the values of A1 cofactors. Thus adjoint of A is nothing but this formula, you know, A11, A12, A21, A22. Let's put the value. A11 is minus 6, A12 is 4, A21 is minus 3, and A22 is 2. So I have this as the adjoint of A. Now I have to prove that A into adjoint of A is equal to adjoint of A into A is equal to A into I. So let's find the value of this first. So what is the value of A into A dja? What is the value of A? A is nothing but 2, 3 minus 4 minus 6. Correct? This is the value of A. this guy into adjoint of A, that is minus 6, 4, minus 3, 2. You multiply this row here, column here, this becomes 2 into minus 6, that is minus 12, plus 3 into 4 is 12. This guy becomes 2 into minus 3, that is minus 6, plus 3 into 2 is 6. Now we'll take this row. Minus 4 into 6 is 24, minus 6 into 4 is 20. Minus 4 into minus 3 is 12, minus plus 6 into minus 2 is minus 2. This is nothing but 0, 0, 0, 0. And that is the value of determinant of A into Y, because determinant of A is 0. So first part is proved. Let's prove the second part. ADJ A into A is nothing but adjoint of A is this set, minus 6, minus 3, 4, 2, and A is this set, 2, 3, minus 4, minus 6. Correct? Let's multiply. You take row here, column here. So this guy becomes minus 6 into 2 is minus 12. Minus 3 into minus 4 is plus 12. Minus 6 into 3 is minus 18. This guy becomes plus 18. Similarly, we will take this row now. 4 into 2 is 8, minus 8, 2 into minus 4. 4 into 3 is 12, and 2 into minus 6 is 12. This is also 0, 0, 0, 0. So if you're finding difficulty in multiplication of matrices, please watch my matrix video, a chapter before this, so we can solve some questions there and clear concepts. This is a determinant chapter, so I'm not focusing much on the matrix multiplication. I'm assuming that you know matrix multiplication. Before starting of this chapter only, I have mentioned clearly that if you want to understand determinant clearly, you should have a clear understanding of matrices. You should know how to multiply two matrices, scalar multiplication of matrices, addition of matrices, subtraction of matrices, properties of matrices. You should know everything about matrices. So if you don't know, please watch the matrix video. And that's how, if you see in this case, we have proved that both are equal to this guy, A mod determinant A into I, because this is nothing but 0 into I, that is 0, 0, 0, 0. Let's take one more example. This is similar to the last example. The only thing is, instead of 2 cross 2, it is 3 cross 3 matrix. It is all the more lengthy actually. So here also what we have to do, first we have to find this mod determinant A, and that if you find, it will come out to be 1 into 0 minus 0, that is 0, plus 1 into 9 plus 2, 11, plus 2 into 0 minus 0, 0. That is 11. So I've got determinant I got, and then you have to find adjoint. For adjoint, you have to find all the cofactors. That's a lengthy process, and then you can find it very simple. We have done so many questions in that. So once you are done with the cofactors, you can find the adjoint of A, and that will come something of this form. You can try this. I won't do this because it will take a lot of time, and we have solved a couple of examples where we have learned how to find cofactors. So end of the day, you get adjoint matrix as this matrix. And now here also we are told to prove that A into adjoint of A is equal to adjoint of A into A, and that is equal to A into I, and A into I is nothing but 11 into I is three-dimensional matrix. So it will be like this, and this will be nothing but 11, 0, 0, 0, 11, 0, 0, 0, 11. Correct? So this will be my matrix, that is determinant A into I. So we have to prove that A into ADJA, that is this guy 1 minus 1 2, 3 0 minus 2, 1 0 3, this matrix into adjoint of A, that is 0 minus 1 2, minus 11, 1 and 8, 0 minus 1, 3. This multiplication is equal to this guy. We have to prove this. And this is doable. You can just try multiplying this. Simple multiplication, you will find that this is equal to this. Similarly, for other way around, that is ADJ A into A also, you have to prove that this is equal to this. So just a simple multiplication, you will try, you will get this answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.